Yum, yum!
Hi, it's Alex. Today we're going to talk about color. I'm going to go through all the different options of the grade node. Then we'll talk about saturation and contrast, invert, clamp, and in the end about what Vibrance slider does. Here I have a standard grade, the individual functions it has into expressions. So you can dissect how the expressions would look like. Each expression has a user tab where you can change the value. By default, I've set them up so they are all set to 0.5, and that's what I'm going to use in the grade node as well. So these are here so you can take a look at what the function does. I just quickly want to go through the functions do visually. Is below 0, or if we have the black clamp on, gets clamped to 0. And this value becomes white point. Does the exact opposite. Anything above that gets pushed into brighter than 1. With white clamp on, it gets clipped at 1. And this value becomes the new 1. Gain is a simple multiply. So if we multiply by 2, 0.5 becomes 1. 0 stays at 0 since it's a multiply, and anything above gets pushed into brighter than 1. Lift is the opposite. So 1 stays fixed and the dark values get lifted or get pushed down depending on where the slider is. Multiply and gain do the exact same thing. It's just basically a second slider in the grade. Offset is a simple add or a plus, so we can just add whatever value we have in here to the whole image, or subtract it, of course. Gamma will bend your curve, so 1 and 0 stay fixed, but the values in between get lifted or get lowered with a logarithmic or with a gamma function. The interesting thing about the gamma is if we add a little color tint to our ramp, since now these curves are all in different heights between 0 and 1, they all get a different bend applied to it. That means if you look at the left, if we lower the gamma, they get spread further apart, which is essentially saturating the image more. And if we push them up, they get closer to 1 and get closer together, which essentially desaturates the image. And you can see that in these individual split up. Saturation, what it actually does is it compresses the difference between red, green, and blue. So if I lower the saturation, all these values just come closer together until red, green, and blue are exactly the same. The nuke saturation node has 4 different kinds of luminance math. You have the average, which adds all red, green, and blue together, divides them by 3. Giving you the average brightness. We have maximum, which just picks whichever red, green, or blue value is the biggest. And since we have always some kind of color value at 1. The maximum saturation basically gives us black where there's no color and 1 where the color wheel is. And then we have Rec 709. So red, green, and blue are mixed according to the Rec 709 specifications. In CCIR 601, that's basically the old PAL spec. I've split them here. We have the average, we have the maximum, and back here I have the Rec 709 and 601 expressions. The average and the maximum just have the normal expressions and a slider. The Rec 709 and the PAL one have the intensity slider as well as the ratios. So these are the ratios in which red, green, and blue get mixed together, and you can see green has the biggest influence in the PAL one as well, though the ratios are slightly different. Next we have contrast. Contrast is actually not a defined function, so every software does it a little bit differently. If we look at the color corrects contrast curve, we can see it looks like that, meaning it's gamma first and then gain down to look something like that. It's not an exact match, but that's basically what it does. First gamma and then expression. You could also get a grade and put it here. A contrast could also look like a lift and a multiply. That's also a valid contrast. There's also the option of doing a roll-off contrast, which does something like that, which is basically the lift and multiply example I just showed. And then you can have a soft clip, which will round off these curves. That's also a valid way to do a contrast. Next up is a simple invert, which just flips the values around. We have a clamp, which picks the minimum value and maps it to 0, and the maximum value and also maps it to 0 in this case. We could also map everything to 1, or map it like that. Or we could clip it like that, so it stays at this and this value. For my expression example, I've done in this example, but where you clamp it to really is just a matter of, do you clamp it to 0 or do you clamp it to the other value, some arbitrary value. Next we have vibrance. If we increase the saturation of something, we are spreading the red, green, and blue values further apart, which in this case means, since blue and red are already at 1, and red, green, and blue are already at 0 down here, we spread them further apart, we get negative values and positive values way over 1. You can see that here we have a red value of 3, green of minus 0.6, minus 0.5 in blue, which is not ideal to say the least. The way we would do vibrance is to do a color space conversion. We are going from linear to something that splits out the saturation as its own channel, and then we are doing a gamma on the saturation channel, and then we are converting it back to linear. So taking a look at the saturation again, if we increase that, we are pushing all the values further apart into positive and negative space. If we are taking a look at the vibrance and pushing that apart, you can see the 0 and 1 values stay the same, and we are only pushing the values in between further apart, which gives a much more pleasing result. We can also enable this one, which gives us a color tint, and then have a look at the ramp, how that is affected. So that's with the vibrance, and that's with the saturation. You can see the lines get pushed further apart. And here, while the lines get pushed further apart, they are not getting pushed into negative or positive space. And that's it for today. I hope you enjoyed this little excursion.
Yum, yum!